This is a video from section 9.3. The directions say to find the solution of the differential equation that satisfies the given initial condition. So we're going to go ahead and start with example 1. Suppose I had dy dx is x e to the y. And my initial condition says y of 0 equals 0. And I'll show you where that initial condition comes into play. But this initial condition tells me we're looking for a specific solution to the differential equation that satisfies that initial condition. Okay? Now we're going to rewrite this differential equation in differential form. So I'm going to collect the y's together and collect the x's together. And so I'm going to rewrite this as 1 over e to the y dy is the same as x dx. And so e to the negative y dy is the same as x dx, right? 1 over e to the y is the same as e to the negative y. Now let's integrate both sides. And so we get e to the negative y dy is the same as the integral of x dx. So on the left side, we get negative e to the negative y, right? That's the integral of e to the negative y dy. On the right side, we get 1/2 x squared plus c. Now, let's look at our initial condition, because the differential equation we find must satisfy that initial condition. So y of 0 is 0 means when x is 0, y is 0. Okay? And so negative e to the negative 0 is 1/2 of 0 squared plus c. And we're going to solve for c. But remember that e to the 0 is 1, e to the negative 0 is 1, right? So negative 1 is 0 plus c. So therefore c is negative 1. So negative e to the negative y is equal to 1/2 x squared minus 1. So we're not done because we want to solve for y. So e to the negative y is 1 minus 1/2 x squared. So I just multiplied both sides by negative 1. So I'm going to take the natural log of both sides, and I'm going to say negative y is natural log of 1 minus 1/2 x squared. Okay? And I don't need absolute values because e to the negative y is positive, and for appropriate values of x, 1 minus 1/2 x squared must also be positive, right? Of course, x has to be restricted for that to be true, or even this equation won't make any sense. And so y is negative natural log of 1 minus 1/2 x squared. And this would be the answer for example 1. Let's go ahead and take a look at example 2. Suppose I had du dt is 2t plus secant squared t divided by 2u. And the initial condition is u of 0 is negative 5. This is really a good question. You'll see what I mean in a minute. So we're going to rewrite this differential equation in differential form, right? So we're going to collect the u's together. So 2u du is the same as 2t plus secant squared t dt. So let's integrate both sides. So the integral of 2u du is the same as the integral of 2t plus secant squared t dt. So on the left side, we get u squared. That's the integral of 2u du. On the right side, we get the integral of 2t dt is t squared. The integral of secant squared t dt is tangent t. And then we're going to add c. Now, when t is 0, u is negative 5. So let's plug that information in. So negative 5 to the second, that's on the left side. On the right side, I get 0 squared plus tangent of 0 plus c. So 25 is the same as c. But u squared is t squared plus tangent t plus 25. And here's where the tricky part comes in, because it's going to be natural to want to do this. If I'm your instructor, I'm going to have you solve for u. And people are going to want to write this. The square root of t squared plus tangent t plus 25. But remember something. Remember that u of 0 is equal to negative 5. So let's see if this function satisfies that initial condition. So we're going to plug in 0. And we get the square root of 0 squared plus tangent of 0 plus 25. But this is the square root of 25. But if you recall, the square root of 25 is 5. That's not the same as negative 5. So the question is, how do I compensate for that? Well, if I put a negative out in front of the radical, then I claim that the initial condition will be satisfied, because then you would end up taking negative the square root of 25. And negative the square root of 25 is indeed negative 5. And so this would actually be the correct answer. U equals negative the square root of t squared plus tangent t plus 25. So really this question is really good in the sense of when you want to solve for u explicitly in terms of t. And that's example 2. Let's take a look at example 3. Suppose I had this one. X plus 3y squared square root of x squared plus 1 dy dx equals 0. And the initial condition is y of 0 is 1. So 3y squared times the square root of x squared plus 1 dy dx is equal to negative x. So I just moved the x over to the other side. So 3y squared dy, right? Collect the y's on one side, collect the x's on the other. And so that'll be negative x over the square root of x squared plus 1 dx. So I want to integrate both sides. So 3y squared dy is the same as the integral of negative x over the square root of x squared plus 1 dx. So let's rewrite that over here. the integral of 3y squared dy is the same as the integral of negative x over the square root of x squared plus 1 dx. And so y cubed is the same as. Now, I'll show you guys a little trick here. I know that the derivative of x squared plus 1 is equal to 2x. And so what I'm going to do is I'm going to insert a 2 up here. But if I insert a 2 up here, that means I have to divide by 2, because that's equivalent to multiplying by 1, right? And so I'm trying to work backwards a little bit here. And I'm going to move the negative out in front as well. And so we end up with negative a half times the integral of 2x divided by the square root of x squared plus 1 dx. So see if we can track here. Y cubed is going to be negative a half. Now, in my mind, I'm integrating 1 over the square root of u du. So, because notice how the derivative of x squared plus 1 is 2x, exactly 2x. So in my mind, I'm integrating 1 over the square root of u du. And I already know that that's 2 square root of u plus c. But u was x squared plus 1. Okay, so I'm going to write negative a half times 2 square root of x squared plus 1 plus c. But the 2's cancel. And so y cubed is negative the square root of x squared plus 1 plus c. But y of 0 is 1. So that says when x is 0, y is 1. So 1 to the third is negative the square root of 0 squared plus 1 plus c. So 1 is negative 1 plus c, so c is 2. So what that says is the following. Y cubed is negative the square root of x squared plus 1 plus 2. Now, I would hope that your teacher would want you to solve for y. And so therefore here, y would be the cube root of 2 minus the square root of x squared plus 1. And that's how you would do this example. And by the way, this is example 3. So let's take a look at one more example for this video. We'll call this example 4. Suppose I had the following. Suppose I had dy dx is x sine x divided by y. And over here, y of 0 is negative 1. So y dy is the same as x sine x dx. So let's integrate both sides. So the integral of y dy is the same as the integral of x sine x dx. So we get 1/2 y squared, right, is. Now, on the right side, we have to integrate by parts. So I'm going to let u be equal to x, and I'm going to let dv be sine x dx. So du is dx, and v is negative cosine x. And so this is uv, which is negative x cosine x minus the integral of b du, which is negative cosine x dx. So 1/2 y squared is negative x cosine x plus the integral of cosine x dx. And so 1/2 y squared is negative x cosine x plus sine x, right? So remember, we're looking for the function whose derivative is cosine x. This is kind of another way to think about that, right? Plus c. Now, when x is 0, y is, let's take a look at our initial condition. So here, y is negative 1, right? That's what it means to say y of 0 is negative 1. And so 1/2 of negative 1 squared is negative 0 cosine of 0 plus sine of 0 plus c. So 1/2 equals, well, the first term is 0, the second term is 0, right? Sine of 0 is 0 plus c, and so c is 1/2. Okay? Therefore, 1/2 y squared is negative x cosine x plus sine of x plus 1/2. Multiply both sides by 2. So y squared is negative 2x cosine x plus 2 sine x plus 1. But I would expect your instructor to ask for y. Getting to here is not so bad, but solving for y, you have to think about that initial condition. And for the same argument as the previous example, if I take the square root of negative 2x cosine x plus 2 sine x plus 1, the problem is it doesn't satisfy that initial condition. And so I have to put a negative sign out in front of the radical to make sure that what I get satisfies that initial condition. And this would be the solution that we are looking for. And that'll conclude this video for section 2.3. We did 4 examples of finding solutions to differential equations that satisfy initial conditions. Okay, thank you.